Well, good day, ladies and gentlemen, and you are almost masters of stoichiometry. We have one concept left, and then you all will be stoichiometry genii or geniuses. I'm not sure what the plural of geniuses is or are. Well, I don't even know what I'm talking about now. So let's get right into stoichiometry because I do understand stoichiometry. Let's see here. Let's consider three molecules of nitrogen dioxide plus water, yielding two molecules of nitric acid and one molecule of nitrogen monoxide, right? Or 3 moles, 1 mole, 2 moles, 1 mole. Good. When you really, hey, what's this word really imply? React 5.95 moles of nitrogen dioxide with excess water in the lab. In the lab. 3.22 moles of nitric acid are obtained. What is the percent yield? Yeeks. Percent yield. I am not familiar with us discussing this yet. Well, we haven't. So let's go to our page of notes. Do, 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 do. Yee-hee. Wow, that looks scary, doesn't it? Yes, it does. We have stoichiometry, and from stoichiometry we go to calculations within stoichiometry, and we talked about some general calculations of moles and grams to moles to grams, and then we went over here and we talked about limiting reagents, and then we talked about excess reagents, and now we want to talk about where do I want to take this? Let's go with a different color too. Let's go blue. Hey, we need to extend the page. Extend the page. Two percentage yield. This is our last calculation we're going to do in stoichiometry. And the place to begin is where? Hey, let's give a definition. What is the percentage yield? Well, what is a percentage yield? It is a measure of the efficiency of a process. That's what I would call it, a measure of efficiency of a process. Now, is this definition really helpful for us? No, this is not so helpful. What's more important to us here is the equation. The equation for percentage yield is what I really want you to know. The definition for a change, I really don't care, but it's always helpful to start with the definition. So what is the percentage yield? The percentage yield is equal to the actual yield divided by the theoretical yield, times 100. Okay, that's simple enough. That's an easy definition. We do need to understand what an actual yield is, and we need to understand what a theoretical yield is. Theoretical yield. And once we understand those two things, this equation is a piece of cake, right? Actual yield. What is the actual yield? This is the amount of product of a product which is actually obtained. Actually obtained. That means, through the process in the lab. So this would be, like in the lab. You actually get it. You can hold it, you can touch it, you can stick it in your ears. In the lab, in the plant. Okay? You'll see words like obtained or other indicators are obtained, produced, right? When you see so much is produced, they're saying, hey, that really happened. This stuff is real. Okay, the actual real yield is real, and so we have to imply that from we have to infer that, right? We have to infer that from the problem. We hope in the problem that that is implied. Good. What's my theoretical yield? Well, my theoretical yield is the amount of a product which is calculated from the limiting reagent a reactant using mole ratio. That is my theoretical yield. It is a calculated quantity. Can I touch that? No. Can I taste it? No. Can I stick it in my ear? No. It doesn't really exist. It only is something that I predict, that I calculate from my limiting reagent. Okay? That's the difference. Cool. Okay, so let us do some problems. When you really, okay, really, what does that imply? That means it is real. If it's real, what is it? That means this is going to be my what? My actual yield. Good. With excess, I get 3.22 moles are obtained. Excuse me. Wrong. What did I do? I have to make sure I'm talking about a product. That's not a product. When you really react, you in the lab you are obtained. Here we go. 3.22 of my product are really obtained. There we go. This is my real amount, and that is a real amount, but this is what? This is my reactant. This is my limiting reactant. Are obtained. What is the percentage yield? Okay. I have an actual yield. What is that? 3.22 are obtained. So I have 3.22 moles of HNO3. Good. What else do I need? I need to get my theoretical yield. Theoretical yield. Good. What is a theoretical yield? Well, it's calculated from what? From the limiting reagent. Okay, let's clean this up so we can read it a little bit. You've made such a mess. I really react 5.95 moles with excess, which means that this must be my limiting reagent. So my limiting reagent is 5.95 moles of nitrogen dioxide. I want to get what? I want to get a product. Which product? I want to get my nitrous acid. So I have 2 moles of nitrous acid per what? 3 moles of nitrogen dioxide. Calculate that. What do I get? I have my magic TI 30XA in front of me. 5.95. Oops, that looks like 5.95. That's good. I got that. I can use my fingers. Divided by 3 times 2. And I get 3.966 moles of nitric acid. So let's see if that makes sense. This is almost 6 divided by 3. Yeah, that works good. That's close enough. Okay, so my theoretical yield is 3.966. What was my actual yield? 3.22 moles. Are they both in moles? That's moles and that's moles. So it's important that everything's in the same units, right? So percentage yield is going to be equal to what? My actual 3.22 moles of HNO3 over my theoretical 3.966 moles of HNO3 times 100. And what do I get? Here we go. 3.22 divided by 3.966 times 100. And I get an 81.2. 81.2% when I round it to 3 sig figs. Yee-hee, that's all there is to it. Hey, can I have more than 100% yield? Sure. Can I have less than 100% yield? Sure. If I have more than 100% yield, what does that mean? That means I obtained more than I should have. If I have less than 100% yield, that means what? I lost something somewhere in my lab technique. You know, I did a poor job. I spilled it. My lab partner ate it. Here you go. You do the last one. Bring me back when you're ready. Well, we want to identify my key information when 21.52 react, okay, of hydrogen, where's hydrogen? Here's hydrogen. It says I have excess nitrogen, so that would mean this is my limiting reagent. What happens? 9.57 moles are really formed, are formed. Are formed, that means are, that's not the subjunctive, that is real. So that means this is my actual yield. My actual yield of what? Ammonia is equal to 9.57 moles of ammonia. What is the percentage yield? So I need to get my theoretical yield. And how am I going to do that? Well, we have to start with my limiting reagent, 21.52 moles of what? H2 times my mole ratio, 2 moles of ammonia per 3 moles of H2. Okay, now just for the heck of it, let's see if we were to estimate this. Well, this is like what, 21. So we'll take 21 divided by 3. That's 7. 7 times 2 is 14. So we know the answer should be something along 14. If I get 150, I know I'm off. So let's put in these numbers. 21.52 divided by 3 times 2, and I get 14.34, 14.346. 14.346 moles of what? Yoink, yoink, ammonia. Good. Percentage yield, percentage yield. Actual 9.57 moles of ammonia over theoretical 14.346 moles of ammonia. And what do I get? 9.57 divided by 14.346 times 100. Oops, times 100. Times 100. How about 66.71? 66.71% is my yield. Great. Hey, that's all there is to it. Now, let me ask you, let's play another game here. What if I gave you, let's see. What if I gave you a percentage yield? I give you a percentage yield, and I give you an actual yield, and I want to know how much of my limiting reagent I start with. Well, what am I going to do there? Well, my percentage yield is going to be equal to my actual divided by my theoretical yield, right? So I have that, and I have that, meaning what? I can calculate my theory. Once I have my theoretical yield, and that's one of my products, right? I can go from my theoretical yield of my product to my limiting reagent using what? Mole ratio, yeah. And then I'd have my limiting reagent. So that's another way I could do a problem with percentage yield. Well, that's it. And you are now masters of stoichiometry. Let the band begin. See ya.